Reading students, I'm going to go over the midterm exam for today's class. So let's check that out. Of course, like the other assessments, it can be found on Schoology, and this one's inside the exams folder, inside the subfolder labeled midterm exam. Click on the assessment, and let's check out these questions. Question 1. What is music technology? Is it A, any device, activity, or concept that aids the production of music? B, a digital audio workstation that supports the production of music? C, electronic musical instruments? Or D, musical instrument digital interfaces? And the answer is music technology is any device, activity, or concept that aids the production of music. Question 2. What is a transducer? Is it A critical component to multi-track recording? B, a device that converts one form of energy into another? C, a device that converts voltage to amperage? Or D, a technology used to enable sequencing? A transducer is a device that converts one form of energy into another. For example, the microphone I'm speaking into right now is a transducer. It's converting the mechanical physical sound energy into electric energy. Question 3. Which music technology activity consists of placing samples along a timeline with a MIDI controller? A, multi-track recording, B, arranging, C, sequencing, or D, sampling? The answer is C, sequencing. It's not always done with a MIDI controller, but a MIDI controller makes this process a little easier. Question 4. What is the name given to a computer-based music production system? A, sequencer, B, production console, C, digital audio workstation, or D, multi-track recorder? Well, a computer-based music production system is generally referred to as a digital audio workstation. Question 5. What music technology activity entails balancing volume, pan, and effects for several discrete tracks for assemblage into a unified whole? Is it A, sequencing, B, mixing, C, mastering, or D, multi-track recording? Well, the music technology activity that assembles multiple sounds into a unified whole is mixing. Question 6. This technology is a computer language protocol used to send musical information from one device to another. Is it A, MIDI, B, microphone amperage, C, transducer, or D, flanging? It's musical instrument digital interface, also known as MIDI. Question 7. This combinatorial sound technique creates different timbres by adding various sine waves together. Is it A, additive synthesis, B, sequencing, C, multi-track recording, or D, amperage override? That is additive synthesis. The Hammond organ does this, as does synthesizers, hence the name. You take one sound, and then you add another sound to it, and then maybe another sound, and the result is a different timbre from where you began. Additive synthesis. Question 8. This device features an electronic motor and gearbox that drives a series of rotating discs and is used to generate musical notes. Is it A, theremin, B, DAW, C, tone wheel, or D, Hammond? Though a Hammond organ features tone wheels, the answer is C, tone wheel. It's a rotating disc placed very near a transducer, like a magnetic pickup. You set the tone wheel spinning, generates a note. You add a few of these together using additive synthesis, and you get the working mechanism of a Hammond organ. Question 9. A bass guitar is an electromechanical instrument. True or false? Which is true. The electromechanical instruments have moving parts. So you have vibrating strings made of nickel over top of magnetic pickups, to be contrasted in your mind from something like a digital synthesizer, which doesn't have any moving parts. An electric guitar, a bass guitar, a Hammond organ, these are electromechanical instruments. Question 10. Sound is the sensation of vibrations. True or false? That's false. I would say that hearing is the sensation of vibrations. Sound is when a vibrating source, like my voice here, sets about into motion a longitudinal wave of compression and rarefaction of air molecules, also known as a sound wave. Question 11. The 5 fundamental attributes of sound are 1. Wavelength, 2. Frequency, 3. Amplitude, 4. Phase, and 5. Velocity. That's true. In science class, they might talk of a few more, like periodicity. But here in music technology, these are the important ones. They are the measurable attributes of sound. We can get out our rulers and our stopwatches and start quantifying the phenomenon of sound. Question 7. Sound above 20,000 hertz is called infrasonic. That's false. Sound below 20 hertz is infrasonic, and sound above 20,000 hertz is ultrasonic. Question 13. The range of human hearing is 100 hertz to 30,000 hertz. Sadly, that's false. We can't hear up to 30,000. Well, we can hear down to 20, but only up to 20,000. Question 14. The phenomenon in which one sound covers up and renders inaudible another sound is called masking. That's true. It's an ever-present problem in music technology, especially in the realm of mixing. Question 15. Phasing occurs with the interaction of 2 or more sound waves. That's true. You have one sound in the atmosphere, and then you add another sound. The sound waves are going to interact with one another. And phasing can cancel each other out or reinforce one another. Usually what happens is a slightly overlapped situation in which they perturb one another, but neither cancel or reinforce one another. Question 16. An octave is an interval that exists in a ratio of 3 to 2. No, an octave is a ratio of 2 to 1. So that's false. Question 17. The 5 subdivisions of the sound frequency spectrum are 1. Low bass, 2. Upper bass, 3. Mid-range, 4. Upper mid-range, and 5. Treble. That's right. Low bass is 20 hertz to 80 hertz. Upper bass is 80 to 320. Mid-range is 320 to 2560. Upper mid-range is 2560 to 5120. And then the treble range is 5120 to 20,000. Timbre describes a sound's unique character or quality. That's right, that's a good, useful word, timbre. It's how you know it's your friend's voice and not your dad's, because their voices are different as far as timbre goes. They could even be saying the same words. A bass guitar and a tuba can play the same notes, but you can tell them apart because of their timbre, because of their unique character or quality. Question 19. Amplitude describes the volume of a sound. True or false? That's right. Amplitude, or intensity, or loudness, the height of the sound wave. And we usually refer to that as volume. Question 20. What is the most important resource an audio engineer can have? A digital audio workstation. B, healthy ears. C, access to good gear. Or D, dynamic and condenser microphones. Well, A, C, and D are all very nice, but unless you have healthy ears, it's impossible to make any sense with professional audio gear. Number 21. What is the outer part of the ear called? A, tympanic membrane. B, ossicles. C, cochlea. Or D, pinna. Well, the part that you can see is known as the pinna. Question 22. What is the name given to the three tiny bones of the middle ear? A, tympanic membrane. B, ossicles. C, cochlea. Or D, pinna. Those three tiny bones collectively are known as the ossicles. Question 23. What is the name given to the sense organ inhabiting the inner ear? A, tympanic membrane. B, ossicles. C, cochlea. Or D, pinna. Okay, process of elimination here. Same options, but the sense organ inhabiting the inner ear is the cochlea. It's shaped like a snail, and it is festooned with hair cells and nerve endings, which convert sound energy into nerve energy to be interpreted by the brain. By what means does the cochlea transmit its sound information to the brain? A, through nerve impulses via the auditory nerve. B, through mechanical energy via the ossicles. C, through physical sound energy via the tympanic membrane. Or D, by electrostatic means through the cochlear membrane. Well, the cochlea is converting the sound energy into nerve impulses and then sending it to the brain via the auditory nerve. What is the best strategy for avoiding hearing loss? A, wear earplugs. B, avoid loud sounds altogether. C, listen at or above 95 decibels. Or D, listen above 120 decibels with earplugs. Yeah, the best way is just to avoid loud sounds altogether. But in a professional audio context, oftentimes your best bet is to wear earplugs. What ailment can occur after exposure to loud sounds? A, auditory shred. B, temporary threshold shift. C, tympanic hemorrhage. Or D, cochlea frenzy. And the ailment is known as TTS, or temporary threshold shift. Sort of feels like there's cotton stuffed in your ears, might be a little bit of pain. You might hear buzzing or ringing, and it is accompanied by decreased sensitivity to hearing. It's a very unhappy ailment. It goes away after a few days. But if you have TTS, you've done some damage to your ears. Question 27. What condition describes ringing in the ears? A. Cotton ear syndrome. B. Bell ringer. C. Tinnitus. Or D. Threshold shift. The answer is tinnitus. I've also heard it pronounced tinnitus. But if you have ringing in your ears, you are suffering from tinnitus. Question 28. Sounds at this decibel level cross over into the realm of feeling. A. 60 decibels. B. 120 decibels. C. 192 decibels. Or D. 100 decibels. The answer is around 120 decibels. Not only do you hear sound, but you can start to experience pain and discomfort. Incidentally, sound at 192 decibels is the loudest sound that can occur on Earth because atmospheric pressure is no longer providing the elasticity at that point, and the molecules can rocket off into space. 120 decibels is when you begin to feel it. Don't listen to sound there. Question 29. Blank is a measurement of a sound's intensity. A. Frequency. B. Pitch. C. Phase. Or D. Loudness. A sound's intensity, or its amplitude, or its volume, that's generally referred to as loudness. And in a pro audio context, you typically deal with loudness via dynamic processors, and especially the limiter. Question 30. What is the unit of loudness? A. Kilogram. B. Decibel. C. Hertz. Or D. Ampere. The answer is B. Decibel. Question 31. What kind of decibel measures acoustic sound pressure? A. LUFS. B. dBSPL. C. RMS. Or D. dBU. A, C, and D are used to measure professional audio, and dBSPL is used to measure volume in science class, decibels relative to sound pressure level. LUFS is loudness unit full scale. That's the newest kind of decibel. RMS is root mean square, or the average output, and dBU is decibel volts. This would be like analog gear. In music technology, it's these two that are very important, LUFS and RMS. RMS is part of the peak RMS meter, or decibels relative to full scale. But the answer here is dBSPL. How many watts per square meter is equal to 0 dB SPL? Is it 0.2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros and a 1? Is it 100 billion? Is it 0.1 or 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros and a 2? Yeah, it's A, which is 10 to the negative 12 watts per square meter. So that's just when you begin to hear a sound. So it's probably just above 0, probably the same degree. Question 33. A decibel is a unit that expresses the ratio between two physical properties like sound pressure and electric energy. That's true. A decibel reflects a fraction or a ratio, sound pressure, level, and electric energy. Question 34. How many watts per square meter is equivalent to 30 dB SPL? I'm not going to read these all off again. A trillion zeros and a 1. B, 0.1. C, fewer zeros and a 1. Or D, 4 zeros and a 1. All right, let's take a look at that. 30 dB SPL. I have the chart and the lecture that deals with it. And this many zeros and a 1. 10 to the negative 9th watt per square meter. 8 zeros and a 1. 1, 2, 3, 4, 5, 6, 7, 8, and a 1. Answer is C. Question 5. Fix that typo too. Before the advent of digital technology, what kind of decibels was used to measure loudness in a professional audio context? A. LUFS, B. dBSPL, C. dBu, or D. RMS. So before digital audio, it was all about the decibel volts, dBu. In the dBu system, a voltage of 0.775 corresponds to what decibel value? 0 dB, 100 dB, 120 dB, or 30 dB. So the way the decibel volt system works is 0.775 is the standardized voltage that corresponds to 0. And then the ratio is expressed whatever your signal is compared to 0.775. And it's generally a negative number. And we still use that in digital audio. We use negative numbers and 0 being the loudest. But the difference is back in the dBu days, you could push a little bit beyond 0. You could go to like 2 or 3. But in digital audio, if you go beyond 0, your sound distorts. Question 37. In the digital realm, what kind of decibels are used? A. dBSPL, B. dBFS, C. dBu, or D. maximum decibels? Though I wish it was D, the answer is dBFS. Decibels relative to full scale. That's the peak RMS, right? You got the hovering white dashes that correspond to RMS, and then the absolute threshold is the peak. That is dBFS. In the dBFS system, what happens to the signal if it crosses 0 dB? A, it distorts. B, it becomes softer. C, it becomes louder. Or D, it turns into voltage. Okay, A. In digital audio, 0 is an absolute threshold that you cannot cross because your audio distorts. Question 39. Measured in LUFS, what loudness level is best for pop music? A, -24, B, -1, C, -14, or D, -200? Yeah, it's between -14 and -11, but I would advise around -14. And that's where YouTube normalizes, and some of the other streaming services also normalize around -14. So you try to go to -11, you're just going to hit a brick wall on those services, and your audio is going to distort. I think -24 is the law for television, which is the reason why LUFS exists, this new loudness unit, due to loud television commercials and the need for a standardized decibel system that corresponds to the human perception of sound instead of digital audio, which is what dBFS measures. LUFS measures the human perception of sound. Though in my experience, LUFS and RMS track pretty close to one another. They're usually 1 or 2 dB apart. Question 40. Which types of signal do instrument and microphone cables carry? A, MIDI, B, digital, C, analog, or D, speaker? Well, if you're hooking up microphone cables and instrument cables, you are preparing to carry analog audio. Jolts and squirts of electricity that correspond to twangs and pings of sound. Analog audio. Question 41. Which signal type has the highest amperage? A. Microphone, B. Analog, C. Digital, or D. Instrument? Okay, well, there's only two here that make sense, microphone and instrument. And out of these two, instrument is a little bit stronger as measured by voltage and amperage. Question 42. Which of the following units measures electric potential? A. Amps, B. Volts, C. Bits, or D. Signal? The electric potential is measured in volts. A battery has a potential. A wall outlet has a potential. And then once it's flowing, then it's amperage. But the potential is voltage. Question 4. Which of the following cable types is balanced? A. Microphone, B. Instrument, C. Patch, or D. Speaker? Out of these cables, it is the microphone cable that is balanced. It has 3 connection points: a signal, a reverse polarity signal, and a shielding or a ground. 3 wires. Question 44. How do balanced cables achieve noise-free transfer of signal? A. By matching amplitude, B. By employing phase cancellation, C. By standardizing frequency, D. By increasing the sound's velocity, or E. By varying the wavelength? Well, balanced cables feature a signal and a reverse polarity signal, so that is phase cancellation. So whenever the sounds are summed at the other end of the cable, at the input, the noise gathered in its travels along the cable will be canceled out via phase. Pretty remarkable. Question 45. This type of phono plug has 3 connection points: A. TR, B. RTS, C. TRS, or D. TTP? If you have 3 connection points on a phono plug, like your headphone wires have, that is tip, ring, sleeve. C. Question 46. This device is used to turn line level into speaker level. A. Amplifier, B. Voltage generator, C. Preamplifier, D. Microphone, or E. Transducer? Line level into speaker level? You need an amplifier for that. This device is used to turn microphone signal into line level. A. Amplifier, B. Voltage generator, C. Preamplifier, D. Microphone, or E. Transducer? Microphone signal into line level, you'll need a preamplifier. You can also turn instrument signal into line level via preamplifier. This device, which is often found on stage, is used to convert unbalanced signal into a balanced signal. A. Direct box, B. Mix window, C. Transducer, D. Mic desk, or E. Amplifier? They're often found at the feet of the performer. They are direct boxes. Say an acoustic electric guitar or a bass or a keyboard. The instrumentalist can plug right into the direct box. It converts it to a balanced signal, and that balanced signal can be sent all the way to the mixing board. Question 49. If you have 2 4-ohm speakers wired in series, then what is the impedance? A. 2 ohms, B. 16 ohms, C. 4 ohms, D. 32 ohms, or E. 8 ohms? If series, then higher. So 2 4-ohm speakers in series will provide an 8-ohm load. Question 50. What is the name given to the electrical concept of resistance? A. Voltage, B. Amperage, C. Impedance, or D. Conductor? The answer is C. Impedance. Okay.